Hi, welcome back. This video is going to introduce the next step in Dungeon Mode development. I'm going to try and port this to PC. So I want it to work on 8286, 286, 386, 486 machines. It's going to be delivered potentially with on 5.25 inch floppy as nature intended, but there may be 720k 3.5 inch. I don't know. Anyway, so I've been looking at various pieces of tooling to help me with this this process. It's really difficult to find a 16-bit compiler that I can run natively on Windows 10, Windows 11. It's just a bit of a nightmare. There's various approaches. I did have something working on Windows 2000. That actually worked quite well with a nice IDE. That was a Borland C. I think it was version 6 or something. And that worked nice. The issue though is around it's moving away from what I have for the Apple II Commodore 64 development environment. Obviously I'm been using Visual Studio Code, and it's where I want to be really. So I was thinking, is there a way of doing this, having a compiler that will run, not only a compiler that will run, but also an emulated environment that will do it? So perhaps you can combine the two. So what I've done is I've installed QEMU, which is a multi-system emulator, and there's not much in the way of a GUI on this. You basically just install it, and you have to come up with your own sort of configuration, and using there's a whole load of programs here that you can use to emulate different systems. So what you end up with is, if you look here, I have the emulation MS-DOS directory. I've just created that, and there's a whole load of disk images in here. I won't go through the individual steps in doing that. I'm going to write that on my blog, so there'll be links to that at some point. But essentially what I've ended up with is a hard drive image running DOS 62, and a whole bunch of image files which are floppy disk images, I've got to say, which is actually the compiler. So the intention here is to run the compiler in a emulation, in essentially a DOS shell, but also then to be able to run the application as well. So that's quite cool. It's actually worked quite nicely. This is the program that gets run. So it's emulating an i386 machine. There's a meg of memory. This is the hard drive image it's going to load from. There's no network, it's just standard VGA, real-time clock. But there's also this thing here. This is one of the great things about QEMU. It's also supported under DOSBox, but it's a little bit more fiddly with DOSBox. This actually mounts a local drive image read-write to a folder on your local machine, which is fantastic. That's cool. Okay, so this will appear to be essentially drive, I think it's drive D colon within DOS, and that will essentially equate to this directory here on my local machine. So I've got the emulator running emulators MS-DOS. I've got development directory MS-DOS. So we should see these files on the PC, on the DOS box. Interesting. So if we run that, you'll see. Let's just open it here. So this is the development environment as we're familiar with. So this is essentially this directory here. And if we have a look, what happens is it will essentially run this compilation in the autoexec bat, and it's using C++, the compiler on the MS-DOS machine. It's probably easier if I just run it. Hang on. So if I run this thing, so it starts QEMU and then bootstraps into MS-DOS. MS-DOS then runs the compilation, and it will echo this back out. So this is failed compilation. I expected it to have failed, but this debug text is actually here. So what's quite nice is you can just run the thing, and you can see the output of the compiler. So this is Turbo C at the moment, version 2. So it's a pretty old compiler, and it's throwing up all kinds of weird issues, but you expect that because it's old. But that's cool. What's great is it's almost like a fire and forget. You run it just like a traditional emulator. The difference is if we go back to this is the MS-DOS machine. Whoops. If we go to C and then we edit the auto exec, boy. There's not much in the way of configuration. I need to do more config really. But essentially all this is doing is some pretty basic commands, standard commands, easy stuff. But it's bootstrapping the compile.bat. So the compile.bat, as we know, is this thing here, which is the same as what we saw here. So that means we can actually easily mess around with the compilation steps on the emulated MS-DOS machine, but straight from Visual Studio Code. Absolutely brilliant. It's really easy. So we run it, and we could even have, if you wanted to, have another batch command there, which calls this one to actually start it. So this is a standard file, right? This is not doing anything that requires any configuration. I've set this as a standard entry point. Fine. We can flex that if you want. That's entirely up to you. But the interesting thing is, it's in theory with this we could have all of the compilation and emulation steps entirely within Visual Studio Code, which is really nice. Obviously, the output is not going to be in here. That's fine. But you would need not just the output, the compiler, but if it did run, you need an environment to run it in. And in this case, MS-DOS, and you could flex all kinds of stuff in terms of the the amount of memory, whether there was sound, network, whatever you want. Actually works really nicely. Now, the choice of Turbo C was really driven by wanting a compiler with not many disk images and easy to set up. There's loads and loads of 16-bit compilers I could have chosen. Obviously, the larger they are, the more disks you've got to start swapping in and out. It can be a bit of a pain. In fact, there are other ones on here. So if we have a look at the directory listings, so I have Turbo C on there, but I also have Microsoft C7, which I can't seem to get to work at the moment. Yeah, it moans. So this doesn't have any form of memory management. Now, that is a conscious decision at this point, and the reason why I've ended up with Turbo C version 2 is purely because if we have a look at this, we type config.sys, there's nothing in it. It's blank. You think, oh, why is that blank? That's not normal for MS-DOS. That is true, but my target for this is my old Commodore PC-10, which is actually an 8088 machine. But I want the stuff to run on an 8086. So if it runs on 8086 with the 640k memory limit, we're going to be golden, and that's fine. Dungeon Raider runs on a 64k Commodore 64, so it should be fine. But yeah, so that's where we are at the moment. I think it's quite a neat little solution for compiling up and debugging MS-DOS programs. When I say debug, there's obviously no interactive debugging on this. This is purely compiler errors, but it's a nice place to start. And I think, the performance of it is actually pretty good. One thing to bear in mind is that there are key combinations that you can use to force a refresh of the file system. But I found it's best just to every time you make a change to essentially shut down QEMU and start again, because it doesn't. I mean, it takes a few seconds to load up, but it doesn't take that much. The more minimalist the configuration, the faster it will start up. And actually, as you can see, it's not that slow. It's pretty good. The other key advantage, of course, is that you're doing the MS-DOS compilation and running of the program, if you can get it to run and compile properly, on a completely separate instance. That's all sort of sat away. But this, because it's on your local machine, as Windows 11 in this case, I've got access to all of the source control bits and pieces. So I can go in there and check files in and out and whatever, and they're absolutely fine. The next steps really would be to flex this a little bit. So setting up an MS-DOS emulated environment, perhaps with different memory profiles. So HiMemSys and EMM386.sys, all that exe, all that kind of stuff. I could essentially target different instances and set up these instances as hard drive images. This is perhaps a bit over the top. It's got a lot of stuff on there. It doesn't really need that much. But I found that this is probably the leanest, quickest way of doing this. So I tried a FreeDOS under VirtualBox, and that works, but it's a bit weird. I've tried DOSBox, that works quite well. I even had it working with Windows 3.1. That was quite good, actually. That was quite good. But the on VirtualBox, I think the minimum for guest editions was Windows 2000. So you can start to share local file system. It doesn't work on that. So you're thinking, okay, so it's going to be Windows XP. Yeah, okay. Well, we're getting into the realms of having to do networking. And what I didn't want to do is to use networking. You know, the idea of sharing a local file system like this is, for me, is absolutely perfect. You know, you can specify it, and in fact, with your compilation, with your the compiler bat or some other program to bootstrap it, you could flex all this stuff. So you could have your own mount points for this, and it wouldn't care. You know, as long as there's a compile.bat on that drive, in this case D drive, then it'll just run, and that's fine. So that could in fact be flexed for each instance of a program that you're trying to debug. Yeah, brilliant. So there are configuration options that I need to investigate, but for now I got a load of weird flipping things. As an aside, I've found that in going through this stuff, I've had to remove a lot of the comments, and it's all a bit messy because it prefers the comments in a particular format. Yeah, there's weird nuances and strange behaviour. I'm obviously not used to Turbo C version 2. It's old, so there's a few challenges there. I think it's the cons outweigh the pros, or the pros outweigh the cons. Yeah. The pros outweigh the cons at the moment. Maybe I'll find a better 16-bit compiler that will work better for what I need. But for now, I think that's probably good enough. Yeah, it's a work in progress. And as I finesse this thing, I'll obviously feedback and let you guys know more. So yeah, that's it for now. I'll see you next time. Cheers.